Hello, it's Florian Musso again from Europe's top university, TUM, at Europe's top blackboard behind me. So we've been talking about vertical structures and horizontal structures, and we've been talking about roof structures. So the subject is going to be foundation. Hey, it's me on the playground, my favorite location. Fortunately, no kids, so I can do my experiment concerning the load, which is my finger, and the ground, which is the sand. So I'm pushing my finger in the ground, which shows the phenomenon that I want to avoid. So what I can do here are different things. Digging deeper and deeper so that the friction will be high enough to withstand the load of my arm, or meeting a rock or something in the ground where I will not be able to get any deeper, or I could go for the surface here, and then I will not be able to push my finger in the ground. Okay, so we have two possibilities, one being a surface foundation, which tries to distribute the rather punctual load on a wider surface. And the second is pile foundation, which is based on friction, and it will be as long as needed to create enough friction to transmit the load from the building to the ground. Pile foundations work in a way that we have been seeing in the sandbox. So one method is to create friction here, and the other method is to have load-bearing piles, which will attain a lower layer of ground, which is of better quality than what is in between. So this is like a column. Intermediate form would be a surface foundation with piles. It's like a ikebana cushion. So you have smaller piles here, micro piles, and all of them together would create enough friction together with this plate to withstand the load above this type of foundation. You can see how pile foundations are drilled into the ground. Foundation of this stair, and you can see that it's wider than the steel column. Here we have a plate, not a strip, not a punctual foundation, but rather a plate, and what comes out as a punctual foundation is a in situ concrete insert in this plate. Here you can see the foundation holding up the fence, and right next to this we have the tree, and the roots of the tree are the foundation of this tree. The surface foundation should be corresponding to the type of load that I have above. So for example, if I have columns, it might be punctual. If I have a wall, it might be a trench. And if I have a whole building, it might be a big plate as well. and we have this type of onion form where the load is concentrated and then it gets weaker and weaker as we get away from the load transmitting surface. As to the material of the foundation itself, it's very often concrete. In earlier days it has been masonry as well, and you can retain that the load is transmitted in an angle of about 60 degrees. If I need it to be flatter, that is possible as well, but then I will have to start to provide rebars which prevent the foundation from cracking, and I want to avoid this by the rebars taking the tension. If I have a building here sitting on a plate and the ground is very bad, I could increase the quality of this ground slab by adding friction piles underneath. So it's me again in sunny Munich. The building sits on a plate foundation that you can see sticking out below me later on, and groundwater is pumped out of this basin, and then it is re-injected in the ground on the other side. So as I dig in the ground to build my foundation, I might have a ditch. Earth pressure gets bigger the more I get into the ground, and this slope of the ditch can be replaced by vertical elements which I can introduce from above. If I have a water level here below the ground, it would flow in the ditch. So if I want to avoid water in my ditch, I can drill a hole on both sides of the ditch and pump water out from this lower level here. And so in the ground, the groundwater level will adapt to this pumping action, and I can keep the ditch free from groundwater. So the groundwater is pumped out of the basin where the building stands in, and then it is re-injected in the ground. Groundwater comes from the Isar, which is only 100 meters away from here. One thing that should concern us, considering the foundation of a building, is frost in winter. And what could happen? What could happen is that the ground is submitted to frost. Frost gets deeper and deeper, and so the frost will freeze the water that is contained in the ground. The water increases in volume, and it will push the foundation upwards, and then the wall will be pushed as well. And in springtime, when frost is disappearing, the building will descend again. And during this process of descending, which is not controlled by us, there will be cracks in the wall. And this is why we have to keep a certain distance between the ground and the maximum appearance of frost in the ground. So here I'm at experimental pavilion of the Architecture Museum of the Technische University. I'm standing on the surface that we are trying to create. It consists out of boards, the boards are resting on the secondary structure here and here, and the secondary structure is linked to the primary structure, and then the primary structure sits on the punctual foundations below me.